This is week number 4. Be Monday, and this would be day 6, and we're also going to do day 7, so it's the whole week. IT Essentials, 15th, work produced for evaluation. Make sure you have identification, images are marked, they have ID. So make sure your work that's going to be evaluated has all the necessary information. We can easily follow it through. Prep for the OS. Install, what to consider, the size, capacity, partitioning the hard drive. We're going to split it up and so forth. What are you going to use the software for, workstation or server? Linux install. And we start talking about motherboards, the objectives. Open source, server, command line, workstation. You get a GUI. Workstation would be like a client in a client server environment. Yeah, think about your work, okay? Make sure it's well put together. We talked again about processor, memory, and storage, magnetic storage, optical storage. We talked about Wi-Fi, 802.11, and the students prepared for their installs. Then Wednesday, 19th, we reviewed some things from Chapter 1, Computer Systems. Learn the basics and understand it. Don't just go through the steps. Use the text and then do other research to dig in deeper to understand the topics. Chapter 2, we looked at the inside. We talked about assembling a system. Of course, we disassembled first and then put them together. We did an OS install. Talked about users. Assessment Monday. Chapter 3, all about motherboards. Covered some key items. Lab review. Form factor, processor, chip state. Bus and expansion slots. Really 4 key chip sets, Intel and AMD, processor sockets, and how big the board is, form factors. For the OS install, created a user class 2018, IT fall 2018, and what software is on there. So all that we should have that in documents. Then we spent some time talking about this idea of storage, moving items from storage into memory, moving from memory to the processor. Remember, everything that moves are bits. We talked about the paths, 64 bits, data bus, the width of it. So we talked about this path between moving items. And we said, how does it manage that? We talked about the clock, millions of instructions per second. We talked about clock speed. And we talked about then everything is synchronous inside the computer through these bus systems. And we actually spent a fair amount of time talking about that. So the movement of the bits, clock, megahertz, gigahertz. That's how many clicks per second. 1,000,000 clicks per second, 1,000,000,000 clicks per second. And then we have things occur based on clock cycles. So over here I did a little example. We have a program instruction brought up into the instruction register inside the processor, executes it, so it has some command and what to do, and then maybe has to go out, get some data, bring the data back up, processing, have an accumulator, register, high-speed staging areas. This is all in the processor. And this would be like in memory. So it takes so many cycles to execute an instruction. So that might take 8 clock cycles. So to use 8 out of that, as an example, if you have a, I don't know, a 2.5, just making this up, gigahertz doing 2.5 billion cycles a second, then it might take 8 of those cycles to do an instruction. So we can see that we would literally be doing millions of instructions per second. And that's it for this week.